Embedded Android platforms are widely used in industrial automation, medical devices, transportation systems, and advanced human-machine interfaces. In these applications, graphical performance directly impacts UI responsiveness, animation smoothness, and overall user experience. With the introduction of the Verdin AM62 Plus module by Toradex, featuring the Texas Instruments AM62 Plus processor, a new graphical performance tier is now available within the Verdin family. In this video, we evaluate and compare the graphical capabilities of the Verdin AM62 and Verdin AM62 Plus using the Kynetics Embedded Android Developer Toolkit. It is a comprehensive development toolkit that accelerates building and testing embedded Android systems directly on target hardware. It includes an optimized Android operating system for the target hardware, an embedded Android SDK, and over-the-air update capabilities, providing a full-featured development platform for rapidly prototyping embedded Android proof of concept. Both platforms were evaluated using 3 different approaches: video playback testing, synthetic GPU benchmarking, and practical 2D and 3D graphics workloads. We began our evaluation with a video playback test, 1080p video at 60 frames per second. On the Verdin 62 Plus, playback was smooth and stable, with no visible frame drops or rendering delays. The system sustained real-time 1080p video playback throughout the test, enabled by its dedicated video processing unit, which provides hardware-accelerated video decoding. On the Verdin 62, there is no dedicated video processing unit. Video decoding relies on general-purpose processing resources, which made it difficult to sustain 60 frames per second under the same conditions. Visible frame drops and playback latency were observed. We then executed a synthetic GPU stress test designed to evaluate advanced 3D rendering capabilities, including complex shader operations, dynamic lighting, particle effects, and scene complexity. On the Verdin 62 Plus, the workload executed under sustained graphical load. This benchmark is extremely demanding and heavily stresses the GPU. Using the OpenGL graphics API, the platform achieved a final score of 641. We also executed the same workload using the Vulkan graphics API on the Verdin 62 Plus, achieving a final score of 813. Under identical test conditions, the Verdin 62 completed the OpenGL-based workload with a final score of 53. While the test executed successfully, the lower score reflects the platform's more limited 3D processing capability compared to the 62 Plus. To further evaluate real-world graphics workloads, we executed additional 2D and 3D graphics tests focusing on rendering performance. On the Verdin 62 Plus, the 2D graphics test demonstrated strong rendering throughput and smooth UI-level performance, achieving a score of 4,490. In the 3D graphics test, the platform sustained complex rendering workloads efficiently, reaching a score of 3,769. We then ran the same 2D and 3D graphics tests on the Verdin 62 under identical conditions. In the 2D test, the platform achieved a score of 1,759, reflecting more limited rendering throughput compared to the Verdin 62 Plus. In the 3D test, the system completed the workload with a score of 1,367. Across all evaluated workloads, including video playback, synthetic GPU benchmarking, and practical 2D and 3D graphics tests, the Verdin 62 Plus consistently demonstrates significantly higher graphical performance than the Verdin 62, clearly positioning it as the stronger platform for graphics-intensive embedded applications. Contact us for more information on our available embedded Android products for your evaluation or development purposes.